In this session, we are going to see that what will happen when we supply the alternating EMF to the resistor, capacitor and inductor. So now we are going to see that AC circuit containing only resistor, that is alternating current circuit containing only the resistor. What will happen when the EMF is equal to sin omega t, E naught sin omega t is applied, so the current I will flow. So E is equal to E naught sin omega t by Ohm's law. When the current flows through this resistor, E is equal to IR. So I is equal to E by R, that E is E naught sin omega t, so E naught by R sin omega t. So E naught by R is what is that? Voltage by resistance, current. So it will become I naught. I naught is the amplitude of the AC current, E naught is the amplitude of the AC EMF. So I is equal to I naught sin omega t. So we arrive that. So we find that if E is equal to E naught sin omega t is given as an input to the resistor, so through the resistor the current value I is equal to I naught sin omega t will be flows through it. So we have to draw the graphical diagram as well as the phasor diagram. This is a very important part in these questions. So by comparing these two equations, with two equations, first equation and the second equation, we come to the conclusion the EMF and the current are in the same phase. So same phase means this is also sin omega t, this is also sin omega t. If the sin 0 means here also 0. So EMF also 0, current also 0. If the sin omega t is 90 degree means sin 91. So E is equal to E naught, I is equal to I naught. So it will be both are going in the same angle. So that is given here. So sin 0, 0. Then for EMF sin 90, that is E naught. So this value is a E naught value. So this value is a I naught value. So this is E naught value, this is I naught value. Again for 180 degree both will become 0, but the amplitude value of the current is less than that of the amplitude value of the EMF, because the current amplitude value is R times less than that of the EMF, E naught by R. So only it will be lesser, but the angle will be same. So this will be represented in phasor diagram very clearly. So this is the x-axis, y-axis. So in this y-axis it will represent the EMF and current. So both the y-axis, EMF and current. In this equation it is the angle theta. So 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. So alternating current and alternating EMF. So the continuous line shows the alternating EMF and the dotted line shows the alternating current flows through the resistor. So both will go in the, this is the EMF. So the current is also going in the same way, but the EMF value is higher than that of the current value. So this is the E naught, this is I naught. So this curve is I naught sin omega t, this is the E naught sin omega t, that is shown here. So the both are in same phase with the angle omega t. Are you clear, students? So with the angle omega t, so both E is equal to E naught sin omega t, EMF and current will be going in the same phase for pure resistive case. Now we are going to see that what is the alternating current for containing only inductor. So the same inductance, or you remember self-inductance and mutual inductance. Here we are going to calculate that, consider the self-inductance equations. So this is the inductor, coil is an inductor, that is the solenoid is an inductor. So when the EMF, alternating EMF is equal to E naught sin omega t is passed through the inductor, so by self-inductance L is equal to E divided by di by dt. So this is the equation we arrived in self-inductance formula. So di by dt, which is, so that minus line we never included, that we have to take only the magnitude. So di by dt, so this minus line I will include because of the Lenz's law, but here we are taking only the magnitude value. So di by dt, so only I put plus. So di by dt divided by E by L. So what is the E? That is the EMF, E naught sin omega t. So E by L sin omega t. So di means this dt comes here. We need only the current. What is the current flow? So for all the case when the EMF is given, what about the current value is our, so AC circuit containing only an inductor, what is the current flows through it? If the AC EMF is passed through it, AC voltage is passed through it. So I is equal to integral di. So integral di will become total current I. E naught by L integral sin omega t. So sin omega t integration is minus cos omega t. So minus cos omega t by omega. So E naught by L which is equal to minus cos omega t by omega. So I is equal to minus E naught by this omega is commonly taken outside, so cos omega t. So E naught by omega L will be considered as amplitude of this AC current flows through the inductor. So I naught will be where I naught is equal to E naught by omega L. So E naught by omega L is the amplitude of the current flows through the inductor I naught cos omega t. So we can write that cos omega t which is equal to sin 90 minus omega t. Cos theta which is equal to sin 90 minus theta. So if the minus will be included in the sin terms, so this pi by 2 comes to this side and omega 2 comes to this side. That is I naught sin plus omega t. So minus into minus plus omega t. Then this minus comes here means minus 90 degree. So I is equal to I naught sin omega t minus 90 degree. So this is the equation we arrived for AC current flows through the inductor. This is the AC EMF given. So comparing these two equation 1 and equation 2, we come to the conclusion the phase angle of the current I is 90 degree less than 90 radians less than that of the EMF value, because this is the omega t is the EMF angle. So this is 90 degree less than that of the EMF for current. Thus we come to a conclusion for in an inductive, that is inductor AC circuit, the voltage is ahead of the phase angle with the current value, or in terms of the current lags behind the EMF both by 90 degree. So by graphical representation, this is the EMF value sine wave, this is the minus cos wave, so it will become like this. If you substitute the value here, very simply we will arrive that is I will here we shows that it is a minus I naught cos omega t. So this curve shows minus I naught cos omega t. Cos omega t is the value. Okay, if sin 0 0, cos 0 1, so it will become 1. We get only minus I naught. Here it is 0 for I naught. Here the I naught value is minus I naught. Again, if the sine value is 90 degree, if the sine value is 90 degree means sin 91, we get EMF or the maximum value for 90 degree. Cos 90 0. So this curve will become 0 here. So dotted line is a current value, that continuous line is a EMF value. I substitute the theta commonly for both the equations, but for EMF sin omega t, for current it is a cos omega t. Again for 180 degree, for cos sin 180 degree is 0, but the cos 180 degree is plus 1. So likewise it will be good, because here the minus is there. So cos 180 degree is minus 1, minus of minus plus, so this will become plus I naught. So likewise it will goes. That only we are written as a minus I naught cos omega t as a I naught sin omega t minus pi by 2. So this will be lagging 90 degree. So if the sine value is 90 degree ahead for EMF, but the cos value in the current value is behind the sine value. This will be shown in the phasor diagram very clearly. Dear students, the phasor diagram is very important. Draw the phasor diagrams clearly, both the graph diagrams and phasor diagrams in examination clearly. So this is as usual shows the EMF phasor angle with omega t. But what about the inductor current? The inductor current is 90 degree behind the EMF value, so it will be comes down. So it will be lesser, comes down with I naught. That's why, because it is a minus I naught, it will come to the negative terms, I naught value. So then comparing the equations, I naught is equal to E naught by omega L with the Ohm's law relation, I naught is equal to E naught by R. So this R must be equal to this omega L must be equal to R. So this R is a resistance of the resistor. But for this omega L must be represents the resistance of the inductor. So omega L plays a role of resistance or in resistive case. How? In the resistor case, R will represent the resistance, means this omega L represents the resistance in inductor case. So it is this omega L. So omega L is a measure of the effective resistance or opposition offered by the inductor to the flow of AC current flows through it because of the self-inductance process. By the self-inductance process, what will happen? The opposition will be take place. So such a non-resistive opposition to the flow of current is called as a reactance. It is called, we have to say that this is as a reactance. It is happens in the inductor. So we will give the name as a inductive reactance. So inductive reactance is XL, X suffix L. L is in the self-inductor X. L. So XL, which is equal to omega L. This omega L will be equal to this inductive reactance. Omega is equal to 2 pi f. So substitute the 2 pi of L. So dear students, in this session we have studied about AC current containing only resistor, AC current containing only inductor. For resistor, both the angles are same. This is E is equal to E naught sin omega t. Here I is equal to I naught sin omega t. Very simple by applying the Ohm's law. But for inductor, E is equal to E naught sin omega t. But I will become minus I naught sin omega t or minus I naught cos omega t or I naught sin omega t minus pi by 2, 90 degree lagging. So that is the difference between the resistor and inductor. In the next session video, next week video, we will see that what is the AC circuit containing in the capacitor and then series combinations of LCR. L is a inductor, C is a capacitor and R is a resistor. So we have to connect all the three components in the series combination. Then we have to supply the AC voltage E is equal to E naught sin omega t. So that is the flow of this syllabus pattern. So this is a very important question as the NCERT point of view. So just read one time and write one time on your own now itself. So self test will be very important. So if you are just read and go means definitely in the examination time this derivation will not come on the exam paper. So practice on your own. So draw the diagram very neatly in your classwork note.